All right, guys. So figured out this whole issue, and I think I'm going to break down our lesson to small problems. So let's take a look at this problem that I was trying to figure out with this whole KP thing. So one small little rule that I did not note is that KP has to always be solved in ATM. So you got to remember that everything needs to be in ATM. That's what solves this whole problem. So the first thing you do is you take the NO and you convert it into 108 TOR, and you're going to convert it into ATM. How do you do that? It's 760 TOR for every one ATM. And then you go equals, and then you're going to solve that part. You're going to do the same thing with the BR2. So the BR2 is going to be done the exact same way. You take the 126 TOR, and then you're going to change that into ATM as well. So this is more 760 TOR again. Okay, so when you do that, what's going to happen is you're going to get some numbers. The numbers for this section will be, let me pull it in for you, 108 divided by 760, which is going to be 0.142. The other one is 126 divided by 760, which is going to be 0.166. And these are in ATM. Now, once you have the ATM, what you're going to do next is then you plug it into the KP like we were doing before. So it's 28.4 is equal to the top one, which we don't have. So we're going to call that x squared all over 0.142 squared and then 0.166. You're going to go equals, and then you're going to take this and you're going to solve for it. So I'm going to take the 28.4 and I'm going to multiply it by 0.142 squared, and I'm also going to multiply it by 0.166. What that gives me is 0.0951 equals x squared. Square root both sides. And this will end up giving me x is equal to 0.308. Now, this is an ATM. So if you want to change it back to TOR, you need to multiply it by 360. So when you multiply this by, or 760, excuse me, 760 TOR for every one ATM. When you do that, what's going to happen is you're going to get 234 TOR. And that's our answer.